It is used to manufacture sodium hydroxide, chlorine, and hydrogen gas. But if the reaction can't happen on its own, how we are going to get these compounds? The answer is we will pass electric current. Okay. So the answer is by electrolysis. Right. So that's what we discussed. Okay. And so electrolysis, what's the difference? Electrolytic cell, what are the important points? So first of all, the reactions are non-spontaneous in electrolytic cell. The reactions are non-spontaneous. So if you want to carry them out, the electrical energy is consumed. This is positive. EMF of the cell is negative. There is one more difference. It is the difference. Can any one of you tell me what's the difference? It's there in the charge of anode and cathode. That's the only difference. Right? In electrochemical cell, remember we studied zinc. We studied zinc and copper. Zinc was negative. Zinc was losing electron on its own. It was negative. And the copper was positive. Zinc was anode. Copper was cathode. In the Daniel cell or galvanic cell.
Yes, sir.
Right. So here everything else is same. Anode oxidation occurs. Cathode reduction occurs. Anode loss of electron occurs. At cathode gain of electron occurs. But the only difference is of the charges of the anode and cathode. In this, the anode is positively charged and the cathode is negatively charged. Okay.
Yes, sir.
So that's the only difference. So anode loss. So who will get attracted towards the anode? As the name indicates, anode, anions get attracted toward the anode. And if they get attracted, what happened to them, Emma? Anions get attracted, they are negatively charged, they come and lose their electrons.
Okay.
Right? Because suppose in this case it is the chloride. So chloride ion will lose electron and will change to Cl2 gas. Okay?
So sir, will it gain electrons or just lose it?
Lose electron because it was minus. So 2Cl minus, I will write the equation, will change to chlorine.
Okay.
And the 2 electrons will come out. So chloride is oxidized. Right?
Yes.
These 2 electrons, there is an external circuit and which is by which the anode and cathode are connected and the current is flowing. These 2 electrons get transferred to cathode. And who get attracted toward the cathode? As the name indicates,
Sir, cation.
cations get attracted, right? So cations get attracted. Cations, you have Na plus, but Na plus is very stable because it is noble gas electronic configuration, right? So H plus, right? So that will get attracted. So H plus get attracted and they go and accept those electrons. So cations come and accept electrons. Means it is a reduction which is happening. And in this case, at anode, oxidation is happening. So in this case, who will get reduced? The Na plus is there, but Na plus has noble gas configuration. So it is there is one more ion because you have taken it in water. So water has H plus also and OH minus also. So H plus will get attracted and it will accept electrons. And hydrogen gas will be liberated. Okay, so hydrogen gas will be liberated at the cathode. At anode, chlorine gas will be liberated. Okay, and the solution will become alkaline because the solution you are left with Na plus and OH minus. The solution will have OH minus. Okay. Now, other examples which all of you must have studied, Ryan, is electrolysis of water that you must have studied in your junior classes. So if you do the electrolysis of water, you get hydrogen and oxygen. Okay, that is a breakdown of water.
Sir,
Yeah.
sir, I had this one doubt. How do we know which one from the reaction which one is the anode and which one is the cathode?
From the reaction,
Yes, sir.
actually anode will be in, if you are breaking down a substance, anode will, you will take positive and cathode you will take negative, right?
Yeah, yes, sir.
So whatever the substance, these are the tubes which you have taken to collect the gases. So whatever the substance which you have taken, suppose if you have taken water, right? So water actually, so what are the ions? H plus and OH minus, right? Oxygen is electronegative. Suppose NaCl is Na plus and Cl minus and water is there. So at anode only anions will get attracted and they will lose their electron, right? And they will change to, this will lose electron and it will change to oxygen, right? And this will, so this is going to happen. The hydroxide ion is going to get oxidized at anode. Oxidation at anode. Because it is minus an ion, so it is going to get attracted toward anode. And this is going to get reduced. This will gain electron. So you are going to get hydrogen gas. Clear?
Yes, sir, clear.
Yeah. So you find out the anions and cation, and accordingly you. So here you will have hydrogen gas, which is being formed, and here you have oxygen gas. Okay. This is water, so slowly they will get collected. Electrolysis of copper sulfate aqueous, what you are going to get? Electrolysis of copper sulfate. So you have taken aqueous means water. Okay. Sometimes you take inert electrode. What do you mean by inert electrode? Yeah, Ryan, Anushka, Imad, yeah, Shail. Inert electrode is actually platinum electrode. So when you take it, suppose you are doing the reaction of copper sulfate or electrolysis of copper sulfate. But if you take iron electrode, okay, if you take iron as electrode, it is going to be a problem because iron itself will get consumed, or it will undergo, it will it itself start reacting. Okay. So
Yes, sir.
sometimes if you are doing the copper sulfate, electrolysis of copper sulfate, you want only you don't want any other metal to come and participate in the reaction, because sometimes you want some pure substances. Okay. So you must take, under that circumstances, you must take inert electrode. Inert electrode are actually the most common inert electrode. Sahil and Ryan is platinum electrode. So platinum electrode actually doesn't participate in reaction because platinum is very less reactive. So so whatever the reaction original copper sulfate electrolysis was happening, that is going to happen, and the platinum will not interfere. It will just provide a surface for the transfer of electric current. Okay, but you can't use iron electrode because in copper sulfate, if you have taken iron, some other reactions may start happening. Okay, that we don't want, right? So copper sulfate aqueous means copper sulfate dissolved in water. If you take, and if you do the electrolysis, you have anode, you have cathode, right? At anode, oxidation is going to happen. OH minus get oxidized easily. So OH minus is actually O2 minus. It's the oxide ion. Okay, NH plus ion. Think OH minus as this. So OH minus, O2 minus or OH minus get attracted toward the anode. Being an ion, and it loses its electron. So you can write it as O plus H plus, in this minus toward the inner. So this minus 2 was because of the 2 extra electron that is going to come out, 2 electrons. But O is going to form the oxygen gas. Okay. So in copper sulfate aqueous electrolysis, oxygen gas is going to get liberated, at the anode, right?
Yes, sir.
And at the cathode you can take copper cathode, no problem in that. And so copper has more tendency. Actually, metal generally lose electrons. Okay, Sahil, Imad, are you getting what I'm trying to say? Metal generally lose electron, but copper, silver, and gold, these are the metals which have tendency to accept electrons. That's why they are precious. Copper, silver, gold, they are used to make coins. Okay, because they don't lose electron, they don't get oxidized easily. Is it clear? So copper is there, and H plus is there in the copper sulfate solution, water. H plus due to water, copper sulfate you have already taken. So who is going to come and get reduced? It is the copper, because though being a metal, you don't expect it to accept electron, but copper, silver, and gold, remember, they have tendency to accept electrons. So copper is going to get reduced over here, and copper ion is going to get attracted. It will accept 2 electrons at the cathode, and it is going to form a copper atom. That copper atom is going to stick onto the rod itself. So it is better to take the rod made up of copper, because some additional copper is going to come and deposit right on this. Is it clear?
Yes, sir. Clear.
Okay, Imad, Sahil,
Yes,
Rayan, right? This is how the electrolysis happens. Okay, so this is so some basic questions will be given to you. How this electrolysis happen? What are the products? Which substance is getting oxidized? Which substance is getting reduced? Okay, so copper, silver, gold have more tendency to get reduced. They want to accept electron. To but on the other hand, the mother metal don't accept electrons. Suppose in the above case, Na plus remained as Na plus, that has not accepted electrons. Okay, because Na plus was very stable. But copper can accept electrons. Copper doesn't oxidize like iron. Iron gets rusted. Okay, but copper doesn't have tendency. It is having very less, or say no tendency to lose electrons. It has tendency to gain electrons. Uh, okay. Earlier times it was much more common. Copper utensils were used to put water, store water. Okay, because copper doesn't get oxidized. So this is the basic theoretical part of electrochemistry. There is a numerical part also. In numerical part, what we are going to do? Can any one of you tell me? What are we going to do in the numerical part of electrochemistry? Yeah, any idea? Anushka, Rayan?
EMF of the cell.
Yeah, what we are going to calculate?
The EMF.
EMF, actually EMF we are not much interested, though we can, because we are not getting the cell. Actually, we need to put the electrical energy. So EMF we were interested earlier when we were making a cell. So we were very much inquisitive. Oh, how much electrode potential we are getting, how much voltage we are going to get. Okay, from the cell which we are making. Okay, but in this case, we are not making a cell, then though the name is electrochemical cell actually, but we are putting electrical energy. But in this case, we are not, because we are putting electrical energy, we are not getting the EMF. We are very much interested in the amount of substance formed, because electrolytic cell is generally used to do some reaction which is not happening on its own and to get some substance or material. Okay, like in metallurgical process you do it. Okay, for refining of copper. Refining of copper is done in the way in which I have shown you. Okay, electrolytic reduction of copper, electrolytic reduction of aluminium from Al to O3. They are very commonly done. So we don't though it is a name is cell, but it's kind of misnomer because it is consuming electricity, is not giving us electricity. So the main our interest will be, because we are putting electrical energy from our side, so the main interest is going to be how much substance is deposited by how much current. Okay, suppose if I want to prepare 10 grams of copper or 63.5 grams of copper, so for how much time should I pass the current of 1 ampere to get 63 grams of copper deposited at cathode? Is it clear?
Yes,
Himad,
sir.
Anushka, Rehan, Sahil, is it clear? So the main interest is how much substance is formed, or the relationship between the amount of electricity passed and the amount of substance liberated or generated. Okay, so this is the main thing which we need to calculate. And how we are going to calculate? So this is, now we are into the quantitative part of electrochemistry. So how we are going to calculate it, it's very, very simple. Okay, there are two laws which will help us. And what are those two laws known as, Imad? Can you tell me? What are those two laws known as? Any idea? They are known as what?
Two laws first.
They are known as Faraday's laws, right?
Faraday.
Yeah, Faraday's law of electrolysis, right? So Kohlrausch's law is actually for the calculation of conduction and all, right? So what is the first law, Faraday's first law? Anyone can help me out to write the Faraday's first law of electrolysis? Any idea to anyone? Rehan and Sahil?
Sir, is it a conductor that is placed in a magnetic field and electromotive forces inducted?
But what is the relationship between the amount of charge passed and the amount of substance? With that, you can tell me. Okay, so the first law, you need to think in that direction. Okay, first law of Faraday's first law says it's very simple, that the amount of substance deposited during the electrolysis is directly proportional to the amount of charge passed. Faraday's first law. It is the mass of the substance is directly proportional to the amount of charge passed through the solution in Coulomb. So this is the first law of electrolysis. Okay, and it's very straightforward. And if you forget, just remember how much mass of the substance is going to form during electrolysis. Or for example, the copper got deposited. So how much copper is going to get deposited? The answer is, you can think in this way, that it is very simple. It is the amount, it is actually the amount of charge passed. So whatever the amount of charge passed, the amount of copper which is deposited is directly proportional to it. Clear? So if you pass more charge, more copper will get deposited. So W is the mass of substance in grams. Okay, I will write it, is directly proportional to Q. Mass of substance deposited if it is solid, but every time it is not going to get deposited. Okay, suppose if you take some, okay, if you take a gas, it will make the gas. Okay, so the mass of the gas form, right? Is it clear to everyone?
Yes, sir.
Okay, so W is proportional to Q, and Q is what? Q is the amount of electricity charge. And Q, what is Q equal to? You must have studied it in your current electricity in physics. Yeah, what is Q? Can any one of you tell me?
So charge. Okay.
Yeah, charge. And it is, how can you relate it to the electric current? Yeah.
Sir, directly proportional.
Yeah, directly proportional. And it is equal to I into T. Clear? I is the current in ampere. Sil, is it clear? And time is in seconds. Right? So W equal to IT. It is proportional to IT. But if you need to remove this proportionality sign, and whenever you remove proportionality sign, you put some constant, and that constant is Z. Is it clear? So this is the Faraday's first. W equal to ZIT. W is the mass of the substance deposited. In grams. And I is the current in ampere. T is the time in seconds. And what is Z? This is very important. What is Z? Can any one of you tell me?
Constant.
Yeah. and this constant is known as electrochemical equivalent of that substance which is getting deposited. Okay, it is the electrochemical equivalent of the substance which you are depositing, and Z is equal to, you can also calculate it, equivalent weight by Faraday's constant. What is the value of Faraday's constant? And what it represents? Tell me. Yeah. Faraday's constant is the charge of 1 mole of electron. Okay. So Faraday, that is called Faraday's constant, and its value is, yeah, Imad, what's its value is? Sahil, its value is 96500 coulomb per mole. Okay.
Yes, sir.
Clear. So equivalent weight of the substance which you are depositing divided by what? Divided by Faraday's constant. That's going to be the Z. Okay. So for let's calculate Z for copper 2 plus. Can you try? What's the Z for copper 2 plus? Yeah. How, just in terms of F, you can tell me. Okay, I will help you out. The atomic mass of the copper is 63.5. Okay. So atomic mass is, so what is the Z for copper? Can you tell me? Yeah, Imad, try it. Anushka.
Thank you.
Yeah. So equivalent weight is atomic mass divided by the charge. So 63, Rayan, 63.5 divided by 2. Why 2? Anushka, why 2?
Sir, because there is the 2 is a charge on the.
Yeah, 2 is the charge. So you equivalent weight, how you find it out? How you find it out? By dividing the atomic weight by the charge. Okay, that's the equivalent weight. Okay, and divided by F, that's it. So if I'm going to write it as F only, that's going to be the electrochemical. You can find its numerical value. Okay, but this is the way in which you are going to do 63.5 divided by 2. Right? Clear? Ryan, Sahil, is it clear to both of you?
Yes, sir. Clear.
Okay. So for aluminium, for Al3 plus, it is going to be 27 by 3 F, because the atomic mass of aluminium is 27 and the charge is plus. So this is the way by which you are going to find it out. Okay, we are going to do the numericals very soon. And this, let me define the second law. Faraday's second law. Faraday's second law is very simple. Not many numericals are going to come for this. It's very, very simple. Rayan and Sahil, I hope you can see and hear me. Okay. So what I'm doing over here is that I have kept 3 electrolytic cells. Imar, can you see it?
Yes, sir.
So 3 electrolytic cells and I've connected them in series. So it means same current is going to flow through them. Same amount of current, Anushka, is going to pass through them because I have connected all of them by a single wire.
Yes, sir.
So if this is the case, so the second law starts from this only. If 2 or more okay. If 2 or more electrolytic cells are connected in series and the same amount of current is passed through them. Because you have connected them one after another, so same amount of current is going to flow through them. So the amount of substance under these circumstances, so when the current is same, the amount of substance deposited in each cell is directly proportional to their what? Equivalent weights. So I hope you are able to understand this.
Sir, I didn't understand this.
Yeah. So there are three cells, W1, W2, W3. Okay, there is a copper sulfate. There is silver nitrate. Okay. There is zinc sulfate, right? Three cells are connected in series. So how much, tell me how much, if you pass the same amount of current, the amount of copper, silver and zinc deposited in these three cells is going to be proportional to the equivalent weights, to their respective equivalent weights. Means it is going to be proportional to the equivalent weight of copper, equivalent weight of silver and equivalent weight of zinc. Now have you understood little bit? I will
Yes, sir.
explain once again. So if the electrochemical cells are connected in series, Imad, Rayan,
Yes, sir.
then the amount of substance deposited in each cell is directly proportional to their equivalent weights. Clear? So amount of substance which is going to get deposited is directly proportional to their equivalent weight. Okay. So how we are going to prove it? The proof is very easy. Very easy. In fact, you can do all the questions by first law only. Numerical questions. The second law, just you can remember, the proof is very easy. Okay. Let me prove it. Okay. So W1, W2, W3, right? These are the mass of the substance deposited. And W1, if you apply the first law also, so what will be the value of W1? Tell me, Anushka. The mass of copper, how much will it be? You just tell me the formula. No need to tell the value. I am not giving the values. What will be the mass of copper? What is how you get the W? Just use this formula.
Sir, ZIT.
Yeah, ZIT. Very good. Z1 IT. W2 equal to Z2 IT. W3 equal to Z3 IT. Right?
Yes, sir.
Yes, sir.
But we know that I into T is same because you have connected the three cells in this one by the one after another. So same charge is going to pass. So I into T is same. Is it clear? So I will cancel I and T. It is the equation. All three values are same. I and T values, right? So now you are left with what? You are left with what?
Z1, Z2.
Yeah, Z1, Z2, and Z3. Because I and T were same for all, so that was not the variable. So I removed it. And Z1 equal to equivalent weight of copper, because in the first cell you have copper, by F. Okay. In the second cell you were having silver nitrate, so equivalent weight of Ag plus or AgNO3 divided by F. And in the third cell it was the zinc sulfate, so equivalent weight of zinc divided by F. Okay, because Z equal to E by F. Clear? So now F is going to get cancelled because it is same, right?
Yes.
Understood?
Yes.
So can you just explain that once again?
Yeah.
Can you just explain the step again? Z1
Yeah.
after Z1, Z2.
Yeah. So you will write W1, W2. I will explain it one again, W3. Okay. So this is I. It is Z1. Z1 is copper. Okay. I into T. Z2 I into T. Okay. And Z3 I into T. So first cancel out this IT, same.
Okay.
Same for all.
Yes.
Because that is same, you are connected. So now the mass of the substance deposited is now directly proportional to Z1, Z2, and Z3. Electrochemical equivalent of the substances. And what was Z? Z was E by F. So F again, the denominator is same, so I will cancel out. That is same. E1, E2, and E3. Clear?
Yes.
So the amount of substance, so that's what the statement said. Read it. The amount of substance deposited in each cell was directly proportional to the equivalent masses of the substances.
Yes.
Okay, and after simplification, we also write at the same part. Is it clear?
Yes, sir.
So we the equivalent masses, so Z is proportional to the equivalent masses of the substances. Right?
Yes.
Okay. So this is the second law. Okay, very simple, but only with the first law you can do all the questions. With the first law you can simply do all the questions. Okay, the second law actually it is used in using the first law because we have used the formula. Okay, so let's do some numerical problems. So Anushka, I hope you understood.
Yes, sir. Understood.
Okay, Ryan, I hope you understood how to do this. Okay, so yeah, let's do some questions are mostly related to the first law. Okay, so do remember this. So okay, what is the electrochemical equivalent of silver? That you need to tell me. And what is the definition of electrochemical equivalent? Can you tell me? Define electrochemical equivalent.
So for electrochemical equivalent, evolved during electrolysis something.
Yeah, Z, right? So, but you need to define it and find its value for silver. When silver is deposited from AgNO3. Okay, it may or may not be given to you. Yeah. So what is the electrochemical equivalent? So first write the formula W equal to ZIT, or you can write W equal to Z into Q also. Is it clear? Okay,
Yes, sir.
because IT is equal to Q, right?
Yes, sir.
Right. So the definition of electrochemical equivalent is very simple. So if you pass 1 coulomb charge, okay, that is 1 ampere for 1 second. If you pass 1 coulomb charge, if Q equal to 1 coulomb, or you can write it as 1 ampere for 1 second. It is same thing. 1 ampere for 1 second is 1 coulomb. What will be the amount of substance deposited? That will be equal to Z into 1. Okay, so Z equal to W. Okay, now we can write the definition. Getting it? So what is electrochemical equivalent? Electrochemical equivalent is the amount of substance deposited when 1 coulomb of electricity is passed through the solution. Clear? Got it?
Yes, sir.
So when I pass 1 coulomb charge or 1 ampere for 1 second, the amount of substance deposited will be equal to Z. So experimentally it can be find out. You need to do a very basic thing. Imad and Rayan, what you can do you can take a cell, pass the current through it just for 1 ampere current for 1 second, and measure how much mass of copper is deposited. Clear? And that is going to be the electrochemical equivalent. Okay, the amount of substance deposited when you pass 1 ampere for 1 second, the amount of substance deposited when you pass 1 coulomb of charge through a cell. So I hope this is clear,
Yes, sir. Understood.
right? Okay, but the definition is very important, so remember it. Imad, Ryan, I hope you understood. Okay, so now we can find its value for AgNO3. What's going to be its value for AgNO3? Yeah, tell me. Yeah. What's the value of value of Z? I will give you some data which will be given in the question. Molar mass of silver is 108. Okay. Now tell me. Yeah. So how you are going to find Z equal to E by F? Remember this formula also. Or remember E equal to FZ. Okay. What is E, Anushka?
Sir, the number of electrons.
E is the equivalent weight.
Yes, sir.
E is the equivalent weight. Right? So what is the an equivalent weight? How you are going to find it out?
Sir,
If-
E is equal to ZIP.
Yeah, molecular weight by the charge N. Okay. This is the equivalent weight. Okay. So how much it is going to be? 108 by 1 into F. So it is going to be 108 by F. Right?
Yes, sir.
Imad, understood?
Yes, sir, understood.
Right. So this way you can find it out very easy. So you can do it experimentally, or so if it is given to you, the molecular weight divided by the charge, and when you divide it by the charge, okay, the charge of the ion which is getting deposited, silver was +1, and divided by F. Right. So let's move to the another question. What is the quantity of charge in coulombs required to deposit all silver present in 250 ml of 1 molar AgNO3 solution? Yeah. Just do it. Yeah, Imad, Anushka, are you trying?
Fine, sir.
Yes, sir.
Yeah. What is the charge required to deposit all silver? You took a solution, 250 ml of solution and 1 molar. So it will be having some silver. So how much charge should I pass in coulomb to deposit all silver? That you need to tell me. right?
Sir, is it 250 by 1000 then? 100.
It is how much?
965.
2, 4.
Oh, okay.
This is the answer. You need to tell me the complete answer.
Okay.
How you are going to calculate it? Anushka, are you trying it?
Yes, sir. Still trying. Not
Yeah,
done.
so yeah, both Anushka, Ryan, Imad, you are going to tell me how I'm going to do it. Yeah. So which formula should I apply? First of all, tell me that. This is the first thing, right?
250 by 1000 and
Yeah.
100.
W equal to ZIT, right?
Yes.
Mm, but what is the mass of the silver which is present in this? Can you tell me? Yeah, Anushka?
Sir, is it
Sir,
27?
Hmm? Actually, mass of the silver you can't find directly. First, you need to find the mole of silver. So this is molarity into volume will give you mole. Molarity equal to mole upon volume in liters. Okay, molarity. So mole of silver, you are going to find out by molarity 1 molar into volume. Volume is 250 ml. 250 ml is 250 by 1000. So that is 1/4. Okay, mole, 0.25 mole of silver, right?
yes, sir.
So this is one thing. Another thing is, so what is the mass? Because I need to put the mass over here.
250.
Mass is mole equal to mass by molar mass.
Okay.
Given mass by molar mass. So mass is mole into molar mass. Okay. 1/4 into 108. So mass of silver that need to be deposited completely is 108/4. Okay, right?
Yes, sir.
And what is the electrochemical equivalent? Electrochemical equivalent of the silver is molar mass by N. Molar mass is 108 by N is 1, charge is 1 into F. Okay. And what is the amount of charge? That is Q. I can write it as Q. Is it clear?
Yes, sir. Understood.
Okay. So what is Q? Q is equal to F by 4. Right? 2 equal to F by 4. So what is the value of F? 96500 by 4. So 4 2s are 8, 4 4s are 16, 4 1s are 4, and 4 2s are 8. 1, 2. This is the answer. Right?
Yes, sir.
So this is the way by which you are going to do the problem. Okay? Understood?
Yes, sir. Understood.
So just little bit calculation is required. Okay? So keep in mind, you need to get the weight, and the solution is given, molarity is given. So find the mole and multiply it by molar mass, so you will get the mass. Okay, so these are some basic numericals which are going to, which can come up in your exams. So be careful about this. Let's do one more problem so that we can have some more practice. Okay, right? So you need to calculate in the other problem, you need to calculate the time. Time in second required to deposit. All silver in 125 ml, 1 molar AgNO3. And the value of current is 241.25 ampere. F is 96500. So just write, I will help you out. Yeah, Anushka, Imad, how you are trying?
I'm trying to calculate this.
So you have, so first mass of silver you can calculate, W. But W is not found directly.
Can we do it for M into V form, moles of AgNO3?
Yeah, molarity into volume.
So sir, using that, sir, I'm getting 0.125 moles. Is it correct, sir?
Yeah, moles of silver. Very good.
Okay. Then after
That,
that,
yeah, moles of silver is 0.1 Getting it? That is molarity into volume. Volume in liter, 0.125 liter. Right? Clear? And what is the mass of silver? Anushka? Tell me. What's the mass? How you are going to find the mass? Mass equal to moles into molar mass, right? Always remember, mole equal to given mass by molar mass, so mass equal to number of moles into molar mass. Okay, right? So it is 0.125 into 108. 108 will be given to you. Okay, so this is the mass of the silver.
So what is it? Mass is equal to moles into again.
Mass in grams equal to mole into molar mass.
Okay. And so how do you get 108?
That will be given to you. This is the molar mass of silver.
Okay.
That will be given in the question.
Okay.
Okay. So mass you got already 0.125 into 108. Don't simplify it, keep it as it is. Okay. We can simplify it later. Okay. Clear? Now the next thing is, come on the right hand side. What is Z? Z is the electrochemical equivalent. When you get silver from AgNO3. What is Z? Z is molar mass. Z is E by F. First of all, write it. Equivalent mass by F into I into T. Okay. What is equivalent mass? Equivalent mass is molar mass by N. N is the charge. F. Right? Okay. So now we will put the values. Anushka, Rayan, what we are going to put? What values are we going to put? Yeah, tell me. Molar mass is given 108. N is AgNO3 is 1 into F. I will keep it F into I. I is 241.25. Into T. 0.125 into 108. Right? 108 will get cancelled. Okay, and what's the time? F into 0.125, okay, divided by 241.25. Is it clear?
Yes, sir, clear.
Okay, so that is going to be the time. So how much? 96500 into 0.125, 241.25. Okay. Right. And now we need to cancel it. So it can be cancelled. Okay, 241 into 4 if you do, it will be how much? 100, and 4 and 5 into 4 if you do. So 4 4s are 16, 9657. It is 965, right? This is the multiple of 965, so it will get cancelled. So it is 965 by 4, 241.25 is 1/4 of 96500, 965. Okay, clear? 241.25 is 1/4 of 965. Okay, so you can cancel it out. So that is 960, or I need to say 965 is just the 4 times of. Okay, it is 400. Is it clear?
Yes, sir. Clear.
Okay, so that is 400 into 125, right? And how much is it going to be? What's going to be the answer? 400 into 0.125. Yeah, Imad, Rehan. Yeah. Tell me. Yeah.
So, 400 into 125, 50,000.
Yeah, it is. Yeah, it is. Yeah, 50 and 0.125 is there. So 1000 remove 3 zeros. Okay, so it is 50, right? Okay. So it is 50 seconds. Okay. But be careful, right? Imad,
Yes, sir.
Ryan, be careful if the time is given in minutes, you need to convert it into seconds. Clear?
Okay. Only if you convert it to seconds, we can get the answer.
Yeah, because if you take the time in hours, or if you take the time in minutes, you're going to get the wrong answer. You need to, because the charge is I into t, time is in seconds.
Okay.
Okay, that you need to be very careful, right?
Yes, sir.
Okay, so let's move on to the next part. What's the next part going to be? That is going to be electrolytic conductance. So what do you mean by electrolytic conductance? Any idea?
Sir, conductance by electrolytic cell.
Yeah, it is the conduct. An electrolytic cell consists of electrolytes or ions. Okay, so it is the conductance due to ions. So you know metals can conduct electricity. All of us know, right? So you have metallic conductor.